about rhombuses, rectangles, and squares. All right. And the number one thing I want you guys to understand is that we are simply just categorizing these shapes. Where do they fit in regards to basically a definition? How can I classify it, categorize it, that type of thing? Okay. What I want you to know about every one of those shapes, those are usually referred to as special parallelograms. Okay. When something's special, there's something that makes it distinct, right? It makes it a little bit different than anything else. Okay. So even though they are parallelograms, there's going to be some properties that distinguish them from just a general generic parallelogram. Okay. So what I want you to know, every rectangle is a parallelogram, right? And every parallelogram is a quadrilateral, correct? So a rectangle is going to have all the properties that parallelograms have. All the properties that we talked about in 6.3 and 6.2. Okay? And because it's a parallelogram, it's also a quadrilateral, so it's going to have all the properties that we talked about in section 6.1 about quadrilateral. Okay? So there's a lot of properties that are existing here for a rectangle. Everything that's a parallelogram, or every property that existed for a parallelogram, and every property that existed for a quadrilateral. But there is something that makes it unique or special or differentiated from just general parallelograms. So there's an additional theorem, an additional property that makes a rectangle different or special. Okay? And then when we go to a rhombus, we do the same thing for a rhombus. And when we go to a square, we do the same thing for a square. Is that doable? Okay? As we move on, it's very, very, very important that we understand the definition of these shapes and understand that when we see the definition, that it's providing all the necessary requirements. It's stating the bare minimum requirement to be that shape. Okay? Nothing more, nothing less. So when I see the definition of a rectangle, we should probably be writing this down. Okay? Definition of a rectangle. A parallelogram. Okay? That's the key thing. Parallelogram with 4 right angles. Some textbooks you'll see it written as a quadrilateral with 4 right angles. Okay? I think maybe it's a little bit better to classify it as a parallelogram with 4 right angles. Okay? Both statements are true. Both definitions would be fine. The more specific we can be, I think that's better. Okay? That's all you need to be a rectangle. So on your test or a quiz that I give you maybe later this week, it's going to have some vocabulary words on it. And it's going to say, here's 20 words that you can click the box on. Okay, click the one that is a parallelogram with 4 right angles. And the number one answer that I get that is wrong is that people want to mark a square. A square does have 4 right angles, right? Okay. But what else do you know about a square? Yeah, it's going to have equal sides, right? We know rectangles don't need that. Okay? Rectangles, generally speaking, the ones we talk about a lot of times, are ones that have unequal sides, right? That's 2 opposite sides usually congruent. That's what the one we talk about. The picture that's up there on the board right now is the rectangle we generally want to talk about. So this definition, parallelogram with 4 right angles, does not tell us anything about the sides. So I don't need any extra requirements or any details about the sides to classify something as a rectangle. The rectangle is classified strictly on the number of right angles you have. Okay? Is that doable? Now, if that's the definition, what makes this thing a parallelogram? Why do we know it to be a parallelogram? Well, if I have a quadrilateral, if I started with quadrilateral, if that was my definition here, so if that word was just quadrilateral, okay, and I said that it's a quadrilateral with 4 right angles, would you agree that you have a quadrilateral with both pairs of opposite angles congruent? Would this angle here be congruent to that angle there? And would this one be congruent to that one? And we had a theorem in section 6.3 that said in a quadrilateral, if both pairs of opposite angles are congruent, then the quadrilateral can be classified as a parallelogram, right? So that's the logic, that's the reason why the definition is probably best if that highlighted word is parallelogram and not quadrilateral. Okay? because we end up developing some of the necessary requirements that make it a parallelogram if we apply that definition correctly. Is that all right? Okay. So, a lot of stuff we already know about the rectangle. How many degrees are there going to be in those four angles? If we add them all up, we're going to get 360, right? And that's because that shape is a quadrilateral. Okay, every quadrilateral has 360 degrees in it, right? Okay. It also has four sides, right? That's the other fact of a quadrilateral. It's kind of easy. But what did you know about both pairs of opposite sides for a parallelogram? What are you going to be able to tell me about that side there compared to that side there? They're congruent and they're parallel. Okay? Because those were facts about parallelograms, right? What are you going to tell me about these two angles? They are congruent, but that's not generally the case for parallelograms, but they're supplementary. Okay? Consecutive angles are supplementary in a parallelogram, right? So that needs to be the case for a rectangle. So as we go through, and there's other stuff, and I got it written down here. Opposite sides are congruent. That's because it's a parallelogram. Opposite sides are parallel. That's because it's a parallelogram. Opposite angles are congruent because it's a parallelogram. Okay? Diagonals bisect each other. Consecutive angles are supplementary. Okay? Those first, 1, 2, 3, 4, 5 statements are simply because a rectangle is a parallelogram, right? It's going to have all those features that parallelograms have. The sixth one that says interior angle sum to 360, that's because it's quadrilateral. Okay? Does that make sense, everyone? The next theorem says, and this is what makes because right now if I just have those 6 statements above, it's just a parallelogram. There's nothing really unique about it. Okay? But this is the additional fact that really makes it special. Okay? When we end up with a rectangle, the diagonals are actually going to be congruent to one another. Okay? The diagonals of a rectangle are congruent. That's the special statement. Along with the definition, obviously, that kind of distinguishes this shape from just a generic parallelogram. Okay? So as we look at this, I think I've got a GeoGebra here, kind of provide insight here for us. All right, so if I look at that shape right there, that's just a generic parallelogram, right? Okay, generic parallelogram. If I look at some distances down here, this distance right there and that distance right there, okay, the 9.85 and the 6.4, those are the diagonals. That's the orange segment and the purple segment. And you see that they're different, right? And that's what we talked about with just a generic parallelogram. They are going to be different. Okay? But the instant that those two numbers become the same, would you agree that that number there and that number there are the same now? Okay? This thing now turned into a what? A rectangle. Okay? And the reason it's a rectangle is that's vertical and that's vertical, right? So those are parallel. That's horizontal, right? So that's parallel. Okay? Meaning that that's a parallelogram and that's a right angle. So that's got to be a right angle up here, doesn't it? If it's parallelogram, consecutive angles have to be supplementary. So that one's 90, so this one up here is 90. If that one's 90, what's this one? 90. And if that's 90, what's this one? 90. So by those features, by basically figuring out that we can have 4 right angles there, we know by definition that makes a rectangle. And with rectangles, we see that diagonals are, in fact, congruent. All right? Now, something that's also kind of beneficial as we're working just to help us see some stuff that we're going to do tomorrow. If I'm interested in, maybe I look at, let me see here. Let me move this point a little bit. So there we go. Maybe I'm looking at this shape, and I want to determine if that shape is a rectangle or not. Okay? It's not as easy as before, right? I'm going to tell you that it is a parallelogram first. Okay? So that we don't have to worry about. But if I want to determine if it's a rectangle, I need to find right angles, right? Okay? That might be maybe the easiest approach. We're going off the definition. It's really easy in the first example to see that a vertical line and a horizontal line are always perpendicular, right? Here, it's not as easy. Let's say I'm looking at that point A there, and I want to determine if there's a right angle here. What would I have to find about that segment right there? That dotted segment and that dotted segment. What quality do I have to know about those things to tell them that they're perpendicular to one another? Find their what? Yeah, I got to find that degree is 90 degrees, but what is the algebra that tells us that? If I want to find out that thing's a right angle, what do I need to know about that and that? They're what? They're slopes, okay? And their slopes are going to be what to one another? They're not going to be equal, right? Nope. What's the relationship between slopes? They're always opposite sine reciprocals. This is going to be really hard if we don't know that fact, folks. It's going to be a very, very long 3 sections, okay? We need to find a slope of that thing and a slope of that thing. Now, I don't know. I told you it's a parallelogram, but I don't know if this thing's a rectangle, so I'm going to ask to find a slope. So that slope there and that slope there. Okay? Now, if they were fractions, that'd be really easy to tell, right? If one was like, 68 over 100, and the other one was 100 over negative 68, that would be really easy because those are opposite sign reciprocals. But here I'm not seeing that. All right? So if I've got 2 numbers that are opposite sign reciprocals, Cameron, give me a fraction. 7/5. So if my fraction is 7/5, what is its opposite sign reciprocal? Okay, so we flip it and we negate it, right? What if I multiply these together? What am I going to get up top?
1.
Careful.
-1.
Careful. What's 7 times 5? 35. It's going to be negative 35, right? What's 5 times 7? 35. What's 35 divided by 35? 1. One of them's positive, one of them's negative, right? So when I multiply those opposite sign reciprocals, I got -1, right? Okay. Well, think about this. What if my slope is m over n? What is its opposite sign reciprocal? Negative n over m. And that gives me negative nm over nm, doesn't it? What's going to cancel out to give me? -1, right? Everything eliminated, right? So this nm is the 35 from above. The negative nm is negative 35, and positive nm is positive 35, right? So they cancel out and give me -1. So what's that telling me about the slopes? The slopes are always going to multiply together to give me what? -1. Okay? If they're reciprocals, the definition of reciprocals, a lot of times referred to instead of reciprocals, you heard the words multiplicative inverses? All that means is that they multiply together to give you 1. Okay? Well, opposite sign reciprocals is saying opposite multiplicative inverses. Okay? So if I multiply these things together, m times m1, okay, those are the 2 slopes that are up here. If I multiply those together, I should get -1. And we see that number does show up, right? Now, what's nice about that is true no matter where that thing goes. You see now I've got different slopes, right? I've got a slope of 0.09 and a slope of negative 10.65 for these dotted lines. But what is their product? Still -1, right? Okay? So no matter where that rectangle goes and whatever orientation it has in the coordinate plane, if I'm able to find its slopes or opposite sign reciprocals, I'm always going to have a right angle there. It's going to be very important that we're able to do that. Okay? The reason I talk about that is that some people are going to do their work and they're going to leave it as fractions, and it's going to be really easy to use opposite sign reciprocals. And then some people, maybe you want to use GeoGebra, you want to use maybe a calculator to change things to decimals, or maybe that's what you're presented with in the problem. How can I, if they're not in fraction form, how can I determine if they're really opposite sign reciprocals? I just multiply their slopes together and see if I get -1. Okay. Talked about that last year in Algebra 1. It's a pretty important standard in Algebra 1. I'll talk about it several times this course so far. Hopefully that's something that starts to sink in maybe a little bit better than what it currently is. So that's the information that we need to know about rectangles. Has all those properties. Diagonals are congruent. Okay. So the diagonals are incongruent. Can it be a rectangle? No. Okay. So if we want to prove something is a rectangle, show its diagonals are congruent. If you want to prove something's not a rectangle, show that diagonals are incongruent. Show that they're different. Okay. And if the diagonals are different, it tells you that it's not a rectangle. So can it have right angles? No, right? Okay. So if I go off of the slope idea, if I show that the slopes are not opposite sign reciprocals, it then tells me that thing's not a right, or not a, if I don't have a right angle, then it's not a rectangle. Okay. So there's a lot of different things that we can kind of use to determine whether something is one of these special shapes. Okay. These special parallelograms. I want to write this as quadrilateral first, but you're going to rewrite it as parallelogram. So if you want to write it first and put parallelogram in there, you can. But some textbooks, like I said, with a rectangle is going to say that it's a quadrilateral with 4 right angles. Okay, well, we classify it maybe a little bit better as a parallelogram with 4 right angles. Same thing happens with a rhombus. We define it, your textbook might even define it this way. It says a quadrilateral with 4 congruent sides. That's all you need to be a rhombus. Okay, so rhombuses are defined off of side lengths. So on your test, when that definition comes up, do not check mark square, because that's not defining a square, is it? Okay, squares are defined off of side lengths and angle measurements. Okay, this is just being defined off of side lengths. Okay, so we've got a rhombus here. Some people like to call it a diamond. Diamond is really not a mathematical word. Okay, so rhombus is the word we're looking for. But think about this. If by definition it's 4 congruent sides, would you agree that that side is congruent to that side? So you have one pair of opposite sides congruent, right? Would you agree that that side is congruent to that side? So you have a second pair of opposite sides congruent, right? And we had a theorem in 6.3 that said if both pairs of opposite sides of a quadrilateral are congruent, which is what we got going on here, right? Both pairs of opposite sides are congruent. It's just a special case where all 4 of them are congruent. But you have both pairs of opposite sides of quadrilateral congruent. Therefore, the quadrilateral is a parallelogram, right? Is that okay with everyone? So that's why we can maybe better define this thing as a parallelogram. A parallelogram with 4 congruent sides. And that's all you need to have a rhombus. Okay? That's all you need. So, if it's a quadrilateral, and then we've been able to determine that it is also a parallelogram, a rhombus should have all those features that quadrilaterals and parallelograms have, right? So just like a rectangle, a rhombus is going to have those 6 initial features. Okay? It says, why are these 6 properties true for a rhombus? It's because a rhombus is a quadrilateral and it's a parallelogram. And we've done this stuff, guys. We've talked about how, an equilateral triangle is isosceles, right? So an equilateral triangle is going to have all the properties that isosceles triangles have. This is just talking about the same type of thing, just more sides now, different shapes. Okay? And that because of that extra side, we get a lot more properties and features. But what makes it special, what makes it a little bit different than other parallelograms, what makes it different than rectangles, what makes it different than the general parallelogram picture that we usually think about is that the diagonals are going to be perpendicular. The diagonals of a rhombus are perpendicular. And that's a huge feature. When we want to prove that a shape is a rhombus, that's kind of the go-to thing. That's going to be the theorem that we want to use so that it creates efficiency for us. All right? We could go off the definition to find four segment lengths. Okay? But we know that distance form is kind of a task, right? It's hard to do. Okay? Doing it 4 times, getting all 4 of them right. Some of us can't do that yet. Okay? But if I want to look at the slopes of the diagonals, that's a little bit easier. And it's a lot quicker. You're going to deal with 2 seconds. The additional theorem is that each diagonal of a rhombus bisects 2 angles of the rhombus. Bisects means what? Say again? Nope. Bi means 2, right? Sext means segments or parts or partitions or sections. So 2 parts, right? And the geometric or mathematical component of that is that they're equal. Okay? So when we bisect something, we get 2 equal parts. So the diagonals are going to bisect angles or cut angles into 2 equal parts. So let's talk about these facts and let's recognize them or visualize them in a generic picture here. If I've got, for instance, let's just talk about the, we know this is a parallelogram, right? But it's a what? What kind of shape is this? It's a rectangle. Okay. And if we look at the slopes of the diagonals, okay, for a rectangle, if I take M2 and multiply it by M3, if we're looking for these slopes, I'm taking this negative 0.57 number and this 0.57 number, okay? If I multiply those together, okay, and I get -1, they'd be perpendicular, right? If I multiply those 2 numbers together, I get that number. So it tells me that these 2 diagonals are not perpendicular, right? Okay, so for a rectangle, diagonals are not generally perpendicular, okay? But when I take this shape and start to move it around a little bit, let's see here if I can get a rhombus. That'd be the easiest thing to do. And actually, now, because of the way these work, if I've got this vertical line and that horizontal line, you're seeing the vertical line here where M1 is. It's not even showing M1 because it's undefined, right? Okay, or this slope, this vertical slope is undefined. This horizontal slope is 0, so then we see that the product is undefined. If you ever get that situation, that tells you that your diagonals are perpendicular, right? Okay. If I look at this shape here, this is the exact same shape, it's just rotated, and I ask it to, that garbage out of there, ask it to look at its diagonals, so those 2. If I look at that slope, which is M1, and that slope there, I'm sorry, M and M1, M1, M, okay. So if I multiply those 2 slopes together, M times M1, you're seeing here that they do give me a product of -1, right? So those 2 things are perpendicular because this thing is a rhombus, okay? Why is it a rhombus? Because that distance, that one, and that one are all the same, right? So by definition, it's a rhombus. And then once you classify it that way, you should have these features of perpendicular diagonals. Okay. Now, what's nice is that we can also say, and we'll talk about this a little bit more detail tomorrow, if I know my diagonals are perpendicular, then I know the thing is wrong. So the converse of that theorem we just wrote down is true as well. Okay. But in a rhombus, diagonals are perpendicular. Okay, so that's nice. And the other thing that people really want to do a lot of times because of the way we draw these things, we usually draw them pretty small. So for instance, if I look at that shape right there, okay, and actually let's go this one. If I didn't have this marking in there of that right angle, and I just look at, it's a rectangle, right? People want to look at that diagonal, that purple diagonal. And if I look down at angle B, okay, they want to say that purple diagonal bisects angle B, okay? They want to say that this angle here, where my cursor is, and that angle there are the same. Does that make sense? Okay? Because they visually look that way a little bit, don't they? Some people they want to take and say, okay, I want to cut that out, and I want to lay it right on top of that one, and they think that's going to happen. Okay? And it even gets worse when we, make that number go to a 5. Those look even more congruent, don't they? But if I look at those angles with a protractor, that angle there is 38.66. Okay? And this angle here that blue one is 51.34. Those are obviously different, right? Okay. However, when we get a rhombus, and let me just go back to, it's just kind of the easiest way for me with this to make a rhombus is to make the diagonals perpendicular. So there I've got a rhombus, right? Let's actually elongate a little bit so it doesn't look like a square. What do you now notice about those two angles? The 56.31 and the 56.31 are the same, aren't they? So there you're seeing that diagonal bisects that angle there. Okay? Is it going to bisect this angle up here? Yep. Okay? Because it's a parallelogram, right? And opposite angles of a parallelogram are congruent. So that entire angle right there is going to be this 112.62. And then that diagonal is going to cut it in half. And it's going to give me 56.31 twice. Is that okay with everybody? What do you know because it's parallelogram? What do you know about that angle compared to that angle? Opposite angles of parallelogram are congruent, aren't they? So angle CAB and angle CDB, they're going to be congruent. But because it's a rhombus, that diagonal is going to cut those little things in half. It's going to cut those angles in half. And that component, that angle right there, is going to be the same as that angle down there. Okay. Now, in coordinate geometry, other than right angles, it's really hard for us to determine these angle measurements. So that might not be a proper that we use directly with the coordinate geometry stuff right now, but it is a useful fact that kind of differentiates a rhombus from other shapes. Okay. Is that doable? All right, so diagonal of a rhombus bisects two angles in the rhombus, and the diagonals are perpendicular to one another. Okay. Now, we've talked about a rectangle, and a rectangle was defined based off of its angle measurements. A rhombus is defined based off of its segment lengths, right? A square is the conglomeration of those two things. We put those two things together, okay? And now it should start off with a quadrilateral with 4 right angles and 4 congruent sides. So it's both those components. But if we've got 4 right angles, that means all angles are congruent. That means both pairs of opposite angles will be congruent. So we take the quadrilateral and classify as a parallelogram. Or we say both pairs of opposite sides are congruent, so it makes quadrilateral and classifies as a parallelogram. Stuff we learned in 6.3. Okay? So a square, by definition, we're going to call it a parallelogram. It has to have both components, 4 right angles and 4 congruent sides. Okay? So let's go through and talk about the properties that this thing's going to have. If it's a parallelogram, it first met the requirements of being a quadrilateral, right? So it's going to have all the properties that quadrilaterals have. It's going to have 4 sides and 360 degrees. We just determined that's a parallelogram. So it's going to have those 6 or 5 additional properties that all parallelograms have. Okay? both pairs of opposite sides congruent, both pairs of opposite sides parallel, both pairs of opposite angles congruent. Diagonals bisect each other, right? Those are the additional things to make it a parallelogram. Okay. Now it has 4 right angles. So if it's a parallelogram with 4 right angles, it can be classified as a what? Careful. I'm going through this. So we've talked about these two things. This was a quadrilateral and then parallelogram, right? Now I keep going through and I read it right there and I stop. So if I were to stop right there, that'd be the definition for a what? A rectangle. So a square has got built into it the definition of a rectangle, right? So is it going to have diagonals that are congruent? Yep, because that's what rectangles have. Okay. But now I'm going to go through and say, okay, it's a parallelogram with 4 right angles, so it's a parallelogram, it's quadrilateral, it's a rectangle. But now, if I would look at just that highlighted stuff, built into the definition is the definition of a rhombus. Okay. So it's going to have all the features that rhombuses have, right? Or rhombi have. So sometimes you see a square being defined as a square is maybe a parallelogram that is a rectangle as well as a rhombus. Does that make sense? Okay. Or it's a quadrilateral that is a rhombus and a rectangle at the same time. Okay. So you can phrase it that way. I'm going to write it this way. And on your tests and quizzes, you're going to see it that way. But if it's a rectangle, it's going to have all the features rectangles have. If it's a rhombus, it's going to have all the features that rhombuses have. All right, and that's what makes a square special. There's nothing additional. Okay, there's no new components to make it different than a rectangle or rhombus. It's just like I said, the conglomeration or the grouping of those two shapes together. Okay. So it's going to have all the properties of quadrilateral, all the properties of parallelogram, all the properties of square, all the properties of a rhombus. Okay. Now, what I'm going to do in the coming days, okay, I'm going to give you something that looks like this, and I know you might not be able to see right now, so let me zoom this lecture. So I'm going to put a list of properties together. Okay, so property 1, 2, 3, 4, 5, 6. Okay, and I might, put in properties that we've talked about, properties that we haven't talked about, that kind of stuff. Okay, and then over here, I'm going to say that, well, I want you to deal with a quadrilateral and then a parallelogram. Spell it right. Then we'll talk about a rectangle. We'll go rhombus and square. Okay, and with these properties that are, there'll be sentences here, and I want you to go through and say, okay, a quadrilateral has that component and it has that component. Is every parallelogram a quadrilateral? Is every parallelogram a quadrilateral? Yes, it is. Okay, so when I start marking off the properties for parallelogram, I better mark off the exact same properties that I had for quadrilateral, right? But there's also going to be some things that are maybe different. So maybe, I didn't want to do that. Let's see here. Maybe that, and that. And there's going to be more than that. But maybe those are the properties that make a parallelogram different than just a quadrilateral. Does that make sense, everybody? And then I want you to go through and say, okay, I'm going to mark all the properties that exist for a rectangle. Well, is a rectangle a parallelogram? So shouldn't a rectangle have that, and then maybe one additional thing that makes it a rectangle? Does that make sense to everybody? Maybe 2 additional things that make it a rectangle? And then we're going to do the same thing for rhombus and the same thing for a square. All right? So there's a lot of facts and properties that you need to keep straight. Okay? And that's hard to do. So I want to give you a visual that's going to maybe allow you to answer questions like this one. Is a rectangle a square? Or is a rhombus a square? Or is a square a rectangle? We've heard those questions before, right? Think about this. Is a rectangle a square?
No.
No. Because by definition, a rectangle is what? Four congruent angles, four right angles. Okay? So it doesn't have enough information, enough requirements to be a square, right? Because a square needs four congruent sides as well. Okay? Is a square a rectangle? Yes, because to be a square, you need four congruent angles and four congruent sides, right? Well, when I get through the four congruent angles, I meet all the requirements necessary to be a rectangle. So a square is a rectangle, but a rectangle is not a square. Remember talking about with triangles? I mean, I said everything we learned about an isosceles triangle is going to be true for an equilateral triangle, because an equilateral triangle is isosceles. It meets that condition prior to getting to be equilateral. Same idea here, okay? To become a square, a shape has to go through the transformation to become a rectangle first, right? Or meet the requirements to be a rectangle first before it can become a square. So a rectangle is not a square, but a square is a rectangle. So how do we answer questions like that? This is how we answer questions like that, okay? The flow chart, these arrows are one-way streets. You can only flow from the tail of the arrow to the tip of the arrow. So every quadrilateral is a polygon, right? Mm-hmm. But every polygon is not a quadrilateral, so you can't go that way. Does that make sense? Okay. So what's nice about this is that if I'm at a rectangle, okay, and I'm trying to check off the properties that rectangles have, first of all, we understand that there's something special that makes it a rectangle, right? So it's going to have one additional or two additional statements that the other shapes don't have. But if it's a rectangle, it had to be a parallelogram first, right? And if it's a parallelogram, it had to be a quadrilateral first. If it's quadrilateral, it had to be a polygon first, right? So a rectangle is going to have all the features a parallelogram had, and all the features quadrilateral had, and all the features polygon had, right? Is a rectangle going to have the features that a rhombus has? No. No, because there's absolutely no way to go along those arrows, those one-way streets, to go from rectangle to a rhombus. Okay? I can't get that. But if I'm at a square, is a square, is that going to be a rectangle before it becomes a square? So it's going to have those properties of a rectangle, isn't it? I can flow from square to rectangle. So a square is a rectangle. Can a square go to a rhombus?
Yes.
So a square is a rhombus, right? Okay. Can I get the parallelogram from square?
No.
Yeah, I can go from square to rectangle to parallelogram, right? I can get down those streets, right? I can go from here to there. Can I go from square to parallelogram? Yeah, but I gotta go through rhombus to get there, right? But it's okay, I can do that. Okay. So a square is going to have all the properties of the shapes that are above. Does that make sense? So that might be something that's useful to you as you answer some of those questions later on. There are two quick theorems here that we want to talk about. It just makes things a little bit easier for us dealing with rectangles. The first one is, I guess, rectangles and rhombuses. Oh, sorry. Don't that up. It says if an angle of a parallelogram. The key thing here is that we know we're dealing with a parallelogram. Okay? So what do you know about opposite angles of a parallelogram? They're congruent. Okay? So this is saying if you know that this shape right here is a parallelogram, okay, you should know that that angle there and that angle there are congruent, right? Well, if this one's 90, what's this one have to be? 90, okay? So this one right here is the A right angle that I'm talking about. Yeah, if I know that one's a right angle, I automatically know that one's a right angle, right? If it's a parallelogram, what do you know about adjacent angles or consecutive angles? They're supplementary. So if that one's 90, what's this one? 90. And then for the same reason, doesn't this one here have to be 90? All right. So based off of being provided this being a parallelogram and that being a right angle, knowing I have one right angle, ultimately shows me or proves to me I have four right angles, right? And then it makes it a rectangle. Okay? But would that theorem be true if I said if an angle of a quadrilateral is a right angle, then the parallelogram is a rectangle? Would that work? Is a quadrilateral the same thing as a parallelogram? No. Okay? So that's probably not going to work, and it will not work. Okay? That parallelogram word has to be there. They interchange, and it's just the nature of things. They interchange parallelogram and quadrilateral all the time. And a lot of people think quadrilateral is the same thing as parallelogram, or parallelogram is the same thing as quadrilateral. They're different words, So they have different meanings, right? Make sure we understand that. The other one is that if we're dealing with a parallelogram again, so let's say that this shape here is a parallelogram, and consecutive sides are congruent. Consecutive means one after another, right? So we name this as side 1, 2, 3, and 4. Okay? If it's a parallelogram, what do you know about side 1 and 3? Yeah, a parallelogram, opposite sides are congruent, right? What do you know about 2 and 4? They're congruent, okay? Well, now this is saying if you can find consecutive sides congruent. Consecutive means one after another, right? Would you agree that 1 and 2 are one after another? So let's say we found those to be congruent. You just told me because it's parallelogram that 2 and 4 had to be congruent, right?
Yep.
And you told me that 1 and 3 had to be congruent, right?
Yep.
So those markings show me that all 4 of those sides are congruent, right?
Yep.
So it makes it a what by definition? Careful. It's a 4-sided figure. It's a parallelogram with all sides congruent. It has to be a rhombus. Okay. We need to go a little bit further. If I could show maybe this angle right here is a right angle, then it would be a square. Okay. Using the theorem above. Do you see how there's a lot of properties here? There's a lot of situations where they say parallelogram, and then a lot of situations where they say quadrilateral. We have to keep them straight. Okay. There's an assignment in Math Excel 6.4 helps you kind of learn these properties a little bit better. But by no means, you get 100 on that, does that mean you know all your properties? You need to make sure that you go through these things, write them out, create flashcards, and that's a good idea. So you can keep things straight, because if you can't keep them straight, 6.5, 6.6, and 6.7 will blow your mind, and probably your grade. Does that make sense? Okay. Have a great rest of the day.
You too.
Thank you.
So